All right, so what we're gonna do here on for the next lab for chemistry 1111 is gonna be the separation of the components of a mixture. So here we have a mixture, but I know that the book over here has a mixture of ammonium chloride, sodium chloride, and silicon dioxide. While that is true, we actually have a different mixture. So for this mixture, we have two components that are going to remain the same. We got sodium chloride and silicon dioxide. The only thing is that we changed calcium carbonate here for ammonium chloride. Okay, so here's the mixture, and the first thing that we got to do is we got to shake the mixture, trying to get it as evened out as possible, as you know. And so once we do that, the next thing we're going to do is we get an evaporating dish, right? And so here we have the evaporating porcelain dish. And so the first thing that we are asked to do is we're going to measure out our amount of mixture out. And so we're supposed to get anywhere from 2 grams to about 3 grams of this mixture. And so the first thing that they want us to do is get the mass of the porcelain dish. And as you can see, the porcelain, the mass of the evaporating dish is going to be 75.35 grams. And just got to double check to see, make sure that you can actually see the mass. Very good. Okay. So then the next thing that we're going to do is we're going to measure out that amount, about 2 to 3 grams, and then record it. And so in doing so, we're going to open it up, and we're going to one of two things that we can do, right? You can zero it out here so that we know how much mass we are going to add, right? So just make sure to record the mass that we just did. And so we're going to add about, I'm going to add about 3 grams. Now, if you're a little under, a little over, all you have to do is not panic, right? A lot of people want to get it right exactly at 3. But if you don't, not a big deal. The only thing that you have to do is just make sure to record whatever mass you did add. And see, for example, for us, right? We did get about 3 grams, so that's just the mass of the mixture in itself, right? And what you don't want to do is make sure you don't spill out anything on the actual pan itself, because then you mess up your, you're gonna lose some of that substance. So here it says 299, 2.99, 3, whatever you want to call it, but we're gonna go with 2.99 because that's actually where it stayed. And then now you have your mixture. And so the first thing that we're gonna do, okay, is once you have your mixture, I'm gonna come over here to this side. So we already measured out our mixture. And so what we're gonna do is now we are going to we're going to add about 25 milliliters of water. And give me a second. Okay, so we're going to add about 25 milliliters of water. And so the reason why we're going to add 25 milliliters of water, because the first step in this step, that according to what they tell us, they first want us to actually heat up the ammonium chloride, right? But since we don't have ammonium chloride, we have calcium chloride. I'm sorry, calcium carbonate. So what we're going to do first in our mixture, since we have calcium carbonate, we have sodium chloride, and the sand. So we're going to exploit a little bit of their physical properties. One of the things that we're going to exploit is the solubility to water. And so we determined that if you look at the solubility rules, or the ability for these salts or substances to dissolve in water, we find that sand is not soluble in water. And we also find out that calcium carbonate is not soluble in water. So because of it, we're going to first dissolve approximately 25 milliliters of water into the evaporating dish, and we're going to stir for about 5 minutes. And then what that's going to do is that's going to actually dissolve the sodium chloride into solution, okay? And so let's go ahead and measure out about 25 milliliters of water. And this one doesn't have to be exact. We're gonna go approximately. So went a little over. Okay. So as you can see, we have about. Oh, you flipped around. Why did you flip around? Oh, interesting. In any case, as you can see, we have about 25 milliliters of water. Right about here. Went a little bit over, so then what we're going to do is then we're going to transfer, okay, those 25 milliliters into the evaporating dish with our mixture. Okay. Now again, remember that this initial step or this initial movement, what we're trying to do here is we're trying to dissolve as much salt as possible into solution. So now we're going to use a stirring rod just to kind of stir the mixture to get rid of as much or place as much sodium chloride as possible into solution. And so we're going to stir for about 5 minutes. So the next thing that we're going to do is after we stirred for 5 minutes of our container, as you can see, I did stir for about 5 minutes, and so now you have a solution, and you have the bottom part, which should be the the calcium carbonate, and your sand, and the solution part should be a sodium chloride solution. And so now what we're going to do is we're going to decant. But before we decant, we need to take the mass of a dry evaporating dish, a different one. And so, whoops, before we do that, let's go ahead and turn on our scale. And as we turn it on, you're going to get the mass of the evaporating dish, right? So you get a mass of 76.3936. And then the next thing is we're going to zero out just in case, and then you're going to get the mass of the evaporating dish and a watch glass together, and so you get a total of 120.72. Okay, now the reason why you're getting it combined together is because right now I'm going to decant just a solution of sodium chloride. And so when I decant over, once you get the mass of that, which is 120.70, that's what we're going to go with. So now the next step that we're going to do is once we get the mass of our watch glass and of our evaporating dish, what we're going to do is we're going to decant over the top liquid part into the evaporating dish. And as we do so, you just want to decant, which means just make sure you get rid of the liquid and make sure none of the solid comes over. And you'll notice that the solid stays behind as much as possible. Okay, hopefully. Alright, well, I got as much of it over as you can see. We have our wet sand. Yeah, it'll be slightly wet. And then you have your solution over here. So then what we're going to do with our solution over here, we're going to close it. And the reason why we're going to close it is because when we start heating the water, what we're trying to do is we're just trying to determine the amount of sodium chloride present. And so in doing so, when we start heating on our Bunsen burner, on top of our Bunsen burner, to evaporate the water, what's going to happen is that sodium chloride is going to start spackling out, and we don't want to lose any of the mass. So we're going to use the watch glass kind of to trap it, and that's why we took the mass of it, the entirety right here of our setup, so that when we get the mass of the sodium chloride, our mass is going to increase, and we're going to take we're going to subtract our final mass together what we have here with the sodium chloride solid, and we're going to subtract it from the initial what the mass of the watch glass was and the evaporating dish, so that we can get our mass of sodium chloride. Okay, so let's go ahead and set up our Bunsen burner now. Okay, so now that we have our setup here, so what I'm going to do is I'm going to place the Bunsen burner underneath, okay? And what we're going to do is we have our setup right here of our solution of sodium chloride with our evaporating dish and our watch glass. And then here we have a mesh net made of metal. The only reason for here is so that it doesn't hit it directly onto, and also creates kind of like a well for the ring, so that the evaporating dish doesn't fall through. And so what we're going to do is we're just going to start it up, and as we can hear the gas coming out, I'm going to go ahead and get a match. And now what we're going to do is we're just going to evaporate off the salt. So what we want to do is we don't want to hit too much, right? We don't want to heat too much. We don't want it to get all crazy on us. So I'm going to heat up slowly. There, I think that one should do. All right. And so as we heat up, we're just kind of wait for the evaporation process to occur, and then we'll come and check up on it right now. I'm going to be on the other side so we can do the extraction of the sand and the calcium carbonate. As you can see, as we're almost close to the end of heating up our salt solution, you can hear a popping sound, and so that's what we were trying to prevent, some of the popping and the spackling to come out as much as possible. And so the observation, as well as you can see, some of the white of the salt is also on the rim of that watch glass. As you can see, as we're heating the salt, you'll notice that the salt now, there is no more speckles of water, and so you don't hear it popping anymore, and hopefully you can see in there. And so the salt seems to be dry. So now what we're going to do is we're just going to remove it, and we don't want to cool it directly onto the plate, right? So we're going to get another a steel mesh, and we're going to place it on the tabletop, and then we're going to transfer over our evaporating dish and let it cool, so that we can make our final mass, so that we can determine the percentage of sodium chloride. Okay. And so how are we going to transfer? We're going to use, there's definitely a couple of things that you could use. Okay, I just want to see if I was recording. So we're just going to go ahead and place our little tongs, and just go ahead and slowly place it on our tabletop. Go ahead and turn off our gas. And we are done, my people, for this part of the heating. Just let everything cool down, and then we'll go ahead and put it back on our scale. And so we'll just let it cool down, get some airflow through the bottom. Hopefully it cools down a little bit faster. Okay. So now we're gonna get the mass of our evaporating dish with the watch glass and our sodium chloride in their solution. So what we're going to do here is going to place it on the scale, and we get a mass of 122.90. And then don't forget to subtract that minus the initial readings for the... Okay, so the next thing that we're gonna do is I've poured out some hydrochloric acid, 3 molar. And so what we're gonna do is we're gonna exploit some chemical properties of these substances. And so now the chemical property that we're gonna exploit is that anytime carbonate salts come into contact with an acid, they tend to form carbon dioxide and a salt in solution. And so what we're gonna do is we're gonna transfer about 10 milliliters, okay? And as we can see, we have still our heat going on all right over here. And so we're going to transfer about 10 milliliters, okay, of our acid into a graduated cylinder, approximately. And then we're going to add slowly that acid into our sand and calcium carbonate mixture over here that is a little bit wet, okay? And so in doing so, once we do that, we're going to eliminate the CO2, right? And then we're going to have some of the calcium, which we're going to end up forming this calcium chloride in solution, and we're going to go ahead and decant that because that is soluble also in solution. Okay, so now what we're going to do is we're going to measure out about 10 milliliters of the acid. We're going to measure about 10 milliliters of the acid. All right, and so once we have our 10 milliliters of acid in our graduated cylinder, we're going to go ahead and add it onto our solution. Now we're going to add it a little slowly. Now you can add little by little onto our mixture, and as you can see, you will start noticing some bubbles. And now we're gonna get our stir again. Now we got the opposite end this time. I'm going to go ahead and stir for about 5 minutes, and then we're going to decant that part and then leave our sand left over. Alright, so now the next part is that once we've stirred for 5 minutes with our hydrochloric acid, 3 molar, and the sand and calcium carbonate mixture, what we're going to do is we're going to decant the top part over again. Okay, so then the next thing that we're going to do is we're going to add heat to our sand mixture so that we can dry it and we can determine the percent amount of sand that is left over from the process. So this should be pure sand, and then of course as we're heating and waiting for our salt to come out, right? And so we're just going to go ahead and wait for it, and we'll see the result of it. Okay. So as we set up the same process of here we have the sand and we are heating. We don't want to heat too much. And so we're going to lower the amount of gas so that it's not crazy. And we're just going to dry the sand. And so that's it. As we wait for the sand to dry, then we will determine what we have left over, and we will do our calculations. We will mass the original container that we had our sand in, and then so that we can deduce how much sand we have left over. As you can see, our sand over here seems to be a little dry already, and so all we're going to do is again turn off the gas. And so as we turn off the gas, we're going to use another one of these metal meshes, and we're going to transfer our container onto the mesh to get some airflow. We don't want to heat it, cool it directly, and onto the countertop, and we'll just let it cool again. Once it's cool, we'll go ahead and make our final measurement so that we can determine the mass of the sand, and then process of elimination, we can definitely calculate our carbon, calcium carbonate. Okay, so now we have the sand here, and so here this is the dried sand. So all we're going to do is place it on our scale so that we can get the mass of our sand. And so don't forget the initial reading of this. This is the original container that contained the main mixture. And so this is going to be 75.87. So subtract that minus the mass of the dish, and that'll give you the amount of the sand.